let's see, this is Math 93, and the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@yvcc.edu and I'll respond as soon as I can. All right, today we're going to start kind of in the middle of chapter 5. If you took Math 85 recently, you would have covered all of chapter 5. If you took Math 84 some time ago, you would have covered the first part of chapter 5. Anyway, we're going to start in section 5.4. There's some material from 5.2 that we'll be reviewing as we go when needed. So that's what we're going to do today. For those of you that have any questions concerning the test you just took, I don't spend class time going over that with students on an individual basis. But if you have questions and want to chat with me about it, email me and I'll track you down and we'll go over those questions if you want. Anyway, having said all of that, we're going to go on to section 5.4. All right. So this is the study of polynomials. Polynomials are algebraic expressions. They are made up of terms. Terms are algebraic quantities that are added or subtracted. Let's say I have 4x squared. This is a single term, and it is called a monomial. Mono, think of a monocle, which is a single lens. I don't know if any of you ever seen reruns of Hogan's Heroes. Commandant Klink had a monocle. It was just a single lens they would hold there. Mono means one, so a monomial is a single algebraic term, okay? Let's say we have two terms, 3x plus 7. This is called a binomial. Bi, as in a bicycle has two tires, a binomial. A binomial has two terms, okay? Let's say we've got 4x squared plus 7x minus 12. This is a trinomial. Tricycle, 3 wheels. Trinomial, 3 terms. If it has more than 3 terms, we just call it a polynomial. Poly means many. So like 7x to the 4th plus 3yw minus 12 plus 8x cubed, whatever, that's a polynomial. Now, in general, these often are all referred to as polynomials. That always bothers me because they'll even include a monomial, which means one, in poly, which means many. But you'll see directions that'll say, do something to the following polynomials, and it might include a monomial. So polynomials, all of them, monomial 1 term, binomial 2 terms, trinomial 3 terms. Okay, terms are separated by addition or subtraction signs. Any questions about that so far? Okay. So have any of you played the game Monopoly, One Mini, Monopoly? Aha, yes, but it's Monopoly, One Mini. Interesting. Okay, now, let's say we have the following binomial, 2x plus 7. There are 2 terms. The first term is 2x. The second term is 7. The coefficient of the first term is 2. Now, the coefficient is a number that's multiplied by a variable or by variables, and it tells how many of them there are. So the coefficient of 2x is 2. There are 2 x's, all right? This is a variable term because it contains a variable. This is a constant term because it only contains a constant or a number. There's no variables involved, all right? Any questions so far? Let's look at another example. Let's look at a trinomial. Negative 3x squared plus 5x minus 17. This has 3 terms. So again, it is a trinomial. The first term is negative 3x squared. The coefficient of that term would be negative 3. So let's go. So coefficient negative 3. The power or degree of this term is 2 or second. Or second degree. Okay, so this term has a coefficient of negative 3. It's a variable term, and the power or degree of the term is 2 or a second degree term. Okay, let's take a look at this term. So the second term is 5x. Its coefficient is 5, and the degree of the term is 1 or first degree. Any questions about that? All right. Now, I said we're going to do some reviewing as we go. Back in section 5.2, and if you find that you need an extensive review and want to do that on your own in the textbook or the ebook online, section 5.2 covers all these rules to do with exponents. And one of the rules is this: a number or a variable, basically anything other than 0, raised to the 0 power is 1. So like x to the 0 power equals 1, 2 to the 0 power equals 1, 734 x cubed all to the 0 power equals 1. Okay. What does that do for us? Well, and this gets a little confusing, but here's the deal. Let's take a look at this term. The third term, oops, can't spell this morning, or any other morning for that matter, is negative 17. The degree of that term is, so the degree is 0. Now, here's the problem. You might say, what if it was negative 17 to the 0 power? It would just be a 1. When we're talking algebraically, a constant term has no visible variable, right? It's just a number. When we're talking about the degree of the term, we're talking about the exponent on the variable. Well, negative 17 doesn't have any variable with it. But suppose we put a variable with it, but we made that variable to the 0 power. X to the 0 power is just 1, so this is still just negative 17. So when we're talking about the degree in terms of algebraic stuff, the degree of that is 0, okay? But again, that doesn't mean it's negative 17 to the 0 power. It basically means there's no variable in the term. So the degree of this term is 2, and then 1, and then 0. All right? Again, that's kind of a hard one to swallow, but open wide and down it'll go. Okay, now, let's say we've got 4x cubed minus 2x squared plus 17x minus 3. This is a polynomial. The first term is 4x cubed. The coefficient of the first term is 4. The degree of the first term is 3. The second term in this polynomial is negative 2x squared. So we pick up that negative sign as part of the term. The coefficient of that term is negative 2. The degree of that term is 2, or a second degree term. The third term of this polynomial is 17x. The coefficient is 17. The degree of the term is 1. Keep in mind there's an implied 1. When there's no exponent written, there's an implied 1 on that base. The fourth term is negative 3. It is a constant term, and it is of degree 0. Now, suppose we want to know the degree of the entire polynomial. The degree of the entire polynomial is equal to the degree of the highest powered term within the polynomial. So this is a polynomial of degree 3. Let's go through this again. The first term is 4x cubed. Its coefficient is 4. The degree of the term is 3. The second term is negative 2x squared. The coefficient is negative 2. The degree of the term is 2, or second degree. The third term is 17x. The coefficient is 17. The degree of the term is 1, or first degree. The fourth term is negative 3. Basically, its coefficient, if we were to label it, would be negative 3. The degree of the term is 0. The degree of the entire polynomial is 3, a third degree polynomial. Any questions about this particular example? Okay, let's take a look at another one. Let's see here. Negative 5x to the fourth plus 3x squared minus 3x. This is a trinomial. It has 3 terms. The first term is negative 5x to the fourth. The coefficient of the first term is negative 5. The degree of the first term is 4. So this is a fourth degree term. The second term is 3x squared. The coefficient is a 3. The degree of the term is 2, or second degree, because there is an exponent of a 2 on the variable. The third term is negative 3x. The coefficient is negative 3, and the degree of the term is 1, or it's a first degree term. The degree of the entire trinomial is 4, or fourth degree. Again, the degree of the entire polynomial is equal to the degree of the highest powered term. Any questions about that? Okay. Is this a monomial, a binomial, a trinomial, or none of these? How many terms are there?
There's a binomial.
How many terms?
A monomial?
There's just one, okay? Terms are separated by addition and subtraction. If this was 9x plus y, or 9x minus y, or 9 plus xy, that would be a binomial. But the whole thing is being multiplied together. Nothing's being separated by addition or subtraction. So this is just a single term. Okay with that? All right. How about this one? 3/5 x to the 4th minus 2/5 x cubed plus 1. Is this a monomial, a binomial, a trinomial, or none of the above? How many terms are there?
A trinomial?
Yes, there are 3 terms. What's the degree of this trinomial?
4.
Excellent. So this is a 4th degree trinomial. What's the coefficient of the second term?
Negative 2/5.
Correct. Okay. 4x squared plus x minus 10. Is this a monomial, a binomial, a trinomial, or none of the above? Trinomial. What's the degree of this trinomial?
2.
2. Excellent. Careful. What's the coefficient of the second term?
1.
Excellent. So x is the same thing as 1 times x to the 1 power all over 1. It's all implied there. So if there's no coefficient written, just a plus sign, it's like plus 1x. What about this? 4y squared minus y plus 10x. Okay. What's the coefficient of the second term?
-1.
-1. Excellent. Okay. Let's see here. 16a squared b cubed plus 8a cubed b to the 4th minus 17ab squared. What's the degree of this polynomial?
4.
No.
7.
7, right? And we hadn't covered this yet. Good job, 7. So if a single term has more than one variable in it, you add up all the exponents. So this term is 5th degree. This term is 7th degree. This term is, 3rd degree, because there's a 1 on the A. So the entire trinomial would be a 7th degree trinomial. So again, if there's more than one variable within a term, you take the sum of all the exponents on all the variables, okay? 7x, y, z. What's the degree of this monomial?
3.
Excellent, because there's a 1 on each of those variables. All right. Let's see. Okay, now we're going to evaluate an expression. So for instance, we have x squared minus x plus 7. We are to evaluate this for x equals 6 and then x equals -2. So we have a trinomial, that's our expression, x squared minus x plus 7. We are going to evaluate it when x is 6. That means we're going to take 6 and substitute it everywhere in the polynomial where x appears. So I'm going to get 6 squared minus 6 plus 7. So I get 36 minus 6 plus 7. 30 plus 7, 37. Any questions about that example? All right, let's take a look at part B. We're going to use the same trinomial to now evaluate it when x is -2. So I get -2 squared minus -2 plus 7. I want to point out that both here and here, I put parentheses around the entire quantity, the 6 or the -2. Since x takes on a value, all of x is all of -2. Now, why is it critical that I write it like that? Because if I write it like that, that would imply that you square the 2, and then add a negative sign. But when it's like this, that's -2 times -2, which is a +4. So it's critical that we have the right grouping symbols. Okay. So going back here, this is going to give us 4. So minus a -2 would be +2 plus 7, 6 plus 7, 13. Any questions about that one? Okay. Let's take a look at some other examples. 3s squared minus 2s plus 8. We want to find part A where s is 1 and part B where s is 0. So when s is 1, we get 3 times the quantity 1 squared minus 2 times the quantity 1 plus 8. Order of operations, we do exponents first. So 1 squared is 1, so we've got 3 times 1. Then the regular multiplication, 3 times 1 is 3, minus 2 plus 8, 1 plus 8 is 9. But again, we do the exponents before the regular multiplication. If s is 0, 3 times 0 squared minus 2 times 0 plus 8. 0 squared is 0. So we get that. 3 times 0 is 0. 2 times 0 is 0. Plus 8. 0 minus 0 is 0. 0 plus 8 is 8. Any questions about that example? Okay. How about this one? 1/3 b squared minus 1/9 b. And we have part A, b equals 9, and part B, b equals -9. This is a binomial, right, of degree 2. All right, if b is 9, we get 1/3 times the quantity 9 squared minus 1/9 times 9. Order of operations, we do the exponent first. So this becomes 1/3 times 81, 9 squared, 81, minus 1/9 times 9. I can come in and reduce this. 81 over 3 is 27 over 1, which then just becomes 27. And then minus 1/9 times 9, the 9 in the numerator and the 9 in the denominator reduce down to 1 over 1. So I end up with -1, which is 26. Any questions on that example? I just love it. My voice cracks. All right. If b is -9, we get 1/3 times -9 squared minus 1/9 times -9. Exponents first, -9 times -9 is still a +81. So I get 81 over 3, which is 27 over 1, which is 27, minus 1/9 times -9. That's going to reduce to -1 over 1. But -1 times -1 is a +1. Okay, the negative times negative is positive. So I get 28. Any questions about that example? Okay. Let's take a look at another problem. Let's see here. This says, evaluate each polynomial for A is -2 and B is 3. Let's say I have the following: A cubed minus 2AB plus B cubed. All right. So if A is -2, we have -2, the quantity cubed, minus 2 times -2 times 3. Again, the -2's go in the place of A's, the 3 goes in the place of B's, and then plus, whoops, 3 cubed. So this A was -2, -2, 3, etc., etc. Okay. Exponents first. -2 times -2 times -2 is -8. Negative times negative is positive times positive is positive. 2 times 2 is 4 times 3 is 12. So -2 times -2 times 3 is positive 12 plus 3 cubed is 27. -8 plus 12 is 4. 4 plus 27 is 31. Any questions about that example? All right. We're going to go back up here and take a look at this situation. It says, construct a table of solutions and then graph the equation. And the equation is y equals x squared plus 1. All right, y equals x squared plus 1. So what we're going to do is we're going to make a table of solutions. Now, here is the advice that I tend to give. If you're graphing an equation and it's something you've never graphed before, so you really have no idea what it looks like, I suggest starting with x values going from -3 to +3. And then after that, if you feel like you need to do something different, do so. But if you've got no clue where to start, I would start there. Okay. If x is -3, then y would be -3, the quantity squared, plus 1, which is 9 plus 1, which is 10. Okay. If x is -2, y equals -2, the quantity squared, plus 1, which is 4 plus 1, which is 5. If x is -1, y equals -1, the quantity squared, plus 1, which is 1 plus 1, which is 2. If x is 0, y equals 0 squared plus 1, which is 0 plus 1, which is 1. If x equals 1, y equals 1 squared plus 1, which is 1 plus 1, which is 2. If x is +2, y equals 2 squared plus 1, which is 4 plus 1, or 5. And if x is +3, 3 squared plus 1, 9 plus 1 is 10. Now, I didn't want to go to all the trouble to switching over to WebAssign and setting up a graph and blah, blah, blah. So I'm just using this grid. -3, 10 wouldn't be on this particular grid. I'd have to change the scale. So I'm just going to leave that out. I'm not going to graph those. But when x is -2, y is 5. When x is -1, y is 2. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 5. Now, one of two things here. Either I've really messed up my calculations, or this is not a straight line. It's not a straight line. This is a second-degree equation, and the graph is what we call a parabola. And it looks like that. I put arrows on it to imply that it continues to go up. For instance, if we had a bigger graph and we were going to graph those points, okay? So that's a parabola. Any questions about this particular graph? All right, let's take a look at another example. Let's graph. Let's see here. Y equals negative x squared minus 2. And once again, I'm going to make a table and go from -3 on the x's to +3. We've got to be careful now. Y equals negative, the quantity -3 squared minus 2. So this is outside of the square. So whatever x is, I have to square it, get the results, and then put a negative sign in front of it. So this is going to be y equals -9 minus 2, which is -11. Okay. If x is -2, y equals negative times -2 squared minus 2, which is, let's see, -2, the quantity squared. The quantity squared would be 4, negative sign in front of it. -4 minus 2 is -6. If x is -1, y equals negative times -1 squared minus 2. -1 squared is 1, but there's a negative sign in front of that. -1 minus 2 is -3. If x is 0, y equals -0 squared minus 2, which is -0 minus 2 or -2. Okay. If x is 1, y equals negative, the quantity 1 squared minus 2, which is -1 minus 2 or -3. If x is 2, y equals negative, the quantity 2 squared minus 2, which is -4 minus 2 is -6. And finally, if x is 3, y equals negative, the quantity 3 squared minus 2, -9 minus 2, -11. All right. Once again, this is going to go outside the graph I have here. So I'll just graph the other points. -2, -6 would be right there. -1, -3. 0, -2. Let's see here. 1, -3, and 2, -6. Let's see here. Hang on. -2, -6, -1, -3. I knew there was something wrong. Oops. Now I've got to recreate that thing that I erased there. No need to panic just yet. We can panic later. All right, so 0, -2 is right there. I put it at the wrong place. Okay, so our graph is going to look like that. Notice this one opened downwards, this one opened upwards. When we get to chapter 10, I think it is, we'll be graphing these kinds of things more extensively. But right now, they're just giving you a little taste of it. Okay, we're going to look at one more of these graphs. Let's say we have the following. Y equals x cubed plus 1. Okay, x cubed plus 1. So again, I'm going to graph with x values from -3 to +3. If x is -3, y equals -3, the quantity cubed, plus 1, which is -27 plus 1, which is -26. We won't be graphing that one on this grid today. Okay. If x is -2, y equals -2, the quantity cubed, plus 1, which is -8 plus 1, which is -7. If x is -1, y equals -1, the quantity cubed, plus 1, which is -1 plus 1, which is 0. If x is 0, y equals 0 cubed plus 1, which is 0 plus 1, which is 1. If x is 1, y equals 1 cubed plus 1, which is 1 plus 1, which is 2. If x is 2, y equals 2 cubed plus 1, which is 8 plus 1, which is 9. And if x is 3, y equals 3 cubed plus 1, which is 27 plus 1, or 28. Okay. Well, let's see. For this one, I can't really graph this one or this one or this one or this one, can I? So -1, 0 is there, 0, 1 is there, 1, 2 is there. This doesn't really give us a good idea. It looks like a straight line, but it isn't. So it might be better if I were to go back and use a bigger piece of graph paper, because let's see, -2, -7 would be, well, it's not going to show up down there, is it? What if we did this? We've got time. Let's do this. Let's go back and let's change our scale. Okay, and let's make this -10, +10, 10, -10. But now we've got to be careful. Okay, so now we can graph, let's see here, that point and that point. Maybe that'll give us a better idea. -2, -7. Okay, now each increment is 2 units. So -2, -7 would be there. Okay. -1, 0 would be there. 0, 1 would be there. 1, 2 would be there. And 2, 9 would be there. Now, this is still not as good as it would be if we made it even larger, but this is what this graph looks like. Okay. All right. So we've got polynomials, monomials, binomials, trinomials, polynomials. We've got coefficients, variable terms, constant terms, the degree of a term, the degree of an entire polynomial, evaluating polynomials by substituting numbers in, and then some graphing here. All right, so anyway, tonight your homework is section 5.4. I will be back this afternoon at 1:15, and I will also be looking over your tests and correcting those, and you know, people that submitted work for the problems they did wrong, seeing if I can give you partial credit and everything, and that will probably take me a day or two to get that all caught up. Anyway, I will be back at 1:15. Otherwise, we'll see you tomorrow. So we'll stop the recording.